In this screencast, we're going to talk about finding and using matrix inverses. We're going to use them to solve systems. The first idea is if I want to solve the equation ax equals b for x, well, then the idea is I multiply both sides by 1 over a, which is a inverse, and then on the left-hand side I get a 1x equals b over a. That's the simplest way to solve an equation. Well, it would be really nice if I could repeat the exact same thing with matrices. If I have a matrix equation, ax equals b, it would be really nice if I could just say, well, let's divide by a. And then the solution would be x is b, the vector b, over the matrix A. But what in the world does it mean to divide by a matrix? And the idea is, rather than dividing by a, we're going to start with our ax equals b. And we're going to multiply both equations on the left by a matrix we'll call A inverse, so that A inverse times A is equal to I. And that ought to equal A inverse B. So our solution is x equals A inverse B, where A inverse times A, or A times A inverse, is equal to the identity. So what we're going to do is we're going to solve this equation, and we're going to try and find out what A inverse is. If we know what A is, then we know what I is. The identity matrix in 2 by 2 systems is 1, 0, 0, 1, and if you go into 3, you just keep on increasing the size. Now, let's just start with a matrix. Suppose we have the matrix 1, 2, 3, 4. If I want to take that matrix and multiply by something and get out the matrix 1, 0, 0, 1, then what needs to go in here? We've got some numbers. How about I put A, B, C, D in? Let's try and find out what those numbers ought to be. Well, this really means if I just look at the first column, I can take the first matrix times the first column to get the first column. So I could write this as 2 matrix products. I've got 1, 3, 2, 4 times AC needs to equal 1, 0. And 1, 2, 3, 4 times BD needs to equal 0, 1. Well, that's the same thing as trying to row reduce simultaneously 2 matrices, where we augment by 1, 0, and then we also augment by 0, 1. Well, notice that the coefficient matrices of both are the same. So rather than trying to reduce both independently, let's put them all into one big matrix. And we're going to put in 1, 2, 3, 4. We'll augment by both simultaneously. So really what we're doing is we're trying to solve 2 systems of equations all at once. And hopefully we'll get lucky and find out what our solution is when we're done. So now we're going to reduce this thing. So to reduce it, the first thing I want to do is I want to take row 2, and I'm going to subtract 3 row 1, which gives me 1, 2, 1, 0. That part doesn't change. We made that a 0. 4 minus 6 is negative 2. 0 minus 3 is minus 3, and 1 minus 0 is 1. Now the next thing I'm going to do is I'm going to take row 1 and add row 2 to it, which will give me 1, 0. If I add the 2, that turns into a negative 2. That turns into a 1. We get a 0, negative 2, negative 3, 1. Now let's take row 2 and divide by negative 2, which gives me 1, 0, 0, 1. On the left, I have the identity matrix. On the right, the negative 2, 1 stay the same. And here I have a 3 halves and a negative 1 half. Well, I just solved 2 systems simultaneously. If I would have ignored the part on the right all the way along, I would have discovered precisely that these numbers are the solutions to that first system. Similarly, these are the solutions to the second system. Well, wait a minute. That means that's the first column of the inverse and the second column of the inverse. I now have the inverse is negative 2, 3 halves 1, negative 1 half. Here is my inverse. Notice if you take this matrix and times it by A, so if I take that matrix and times it by A, I end up with the identity matrix. You can check that arithmetic yourself. We're not going to use that. I'm going to solve this system. Well, this is the system 1, 2, 3, 4 times by a vector xy equals 5, 2. Well, this is an A, x equals b. How do I solve it? The answer is x is A inverse times b. Well, A inverse is, we already got it, negative 2, 1, 3 halves, negative a half. B is our 5, 2. And so if I multiply those out, remember that's 5 times the negative 2, 3 halves, plus 2 times 1, negative 1 half, which is precisely negative 10, plus 2, and 15 halves minus 2 halves, or negative 8, 13 halves. Well, now that I have the inverse, I could quickly solve the second system as well. The only thing that changes is the 5, 2 from over here became a 3, negative 7. So if I put that 3, negative 7 right there, I can get a solution as well by taking the 3, negative 2, 3 halves, minus 7, 1, negative a half, and getting my answer out as well. I'm going to let you finish that arithmetic. That's the idea of using an inverse and finding an inverse.